Heinemann Higher, Graphs of Functions, Chapter 3, Exercise 3b, Question 10. Another higher question. This time you've got these two graphs drawn. It tells you that this is a parabola because it says it's a quadratic function. So you know something about it this time. It's not just any old shape there. And it says it's got a stationary value at 1, 0. Hence, find the exact form of y equals f of x. Well, since it's a quadratic, the basic quadratic would look like this. Y equals x squared. And any transformation of it would involve the various moves, stretching it, moving it up and down, compressing it, moving side to side. Well, in this case, you can see that it's been moved one to the side, so straight away I know it's going to be x minus 1 squared. It's not been moved up or down at all, so there's no plus. The second thing is going through 2 here means there might have been some multiplication involved. So you could find if it's been stretched by checking with that point 2. Because at x equals 0, you've got the answer 2. So using that point 0, 2, I can say when y is 2, x is 0. Well, negative 1 squared is 1, so that means k is 2. So that means the equation is y equals 2 times x minus 1 squared. Although it says find f of x, I suppose I should really say f of x equals 2 times x minus 1 squared. In that squared form of it. Or you could multiply it all out, but I imagine it would be okay like that. Because multiplying it out would be double the square of that bracket, so it will be 2x squared minus 4x plus 2. Right. B. Find the coordinates of the point A where this graph cuts the y-axis. Now you know where it cuts the x-axis because that transform graph just says turn it upside down, x plus a half, move it back a half. So it cuts there at a half 0. But where does it cut here? Where does it cut the y-axis? Well, you could just use that formula. There's 2 ways. You could just use that formula by saying this. Well, what do I know about the point A? Well, at the point A, x is 0. Which means the y-coordinate should be, putting it into that formula, negative f of 0 plus a half. So it's negative, and then just use the function f we've got here. 2 times, and then it's a half I'm going to put in there, because that part comes f of a half, so put a half in, minus 1 squared. So it's negative 2 times negative a half squared, which is positive a quarter. Negative 2 times a quarter, which is negative a half. Which means A must be the point 0, negative a half. That way, just by using this formula and substituting x equals 0 into it. Another way you could do it is this. You could say, well, where would that point have come from? That point would have come from this point here, switch it back, which means I've now gone forward a half, and then up a half. It would have come from this point here. So whatever that distance is, that'll be the same distance it goes down the way, which is the same as saying put a half into that formula for that one, put a half into this, you get the same answer, and then flip it over and you get the negative a half. Either way we do it. That's probably better because it just uses the formula. Right, that's 10.